Do I actually get more time? All right. I don't know. People are going to be upset if I start 3 minutes earlier. They're still rolling in. No, start? All right. Everyone, so my name is Rob Lee, one of the 18,000 Rob Lees that are running around in cybersecurity at this point. I'm going to get the volume of this thing down, whether it's going to kill me or not. So 3 years ago, maybe 2 years ago, I started, being asked a lot of questions about AI, and I have to admit, I don't know that much about AI. I'm still learning. I am, like many of you, struggling on a daily basis, and I think it's important to call out the fact that not everyone rolling around here is, in fact, an expert. I basically dabble a heck of a lot at this point. I am learning on a daily basis, and I find when you end up starting to really focus in on this stuff, the more you feel overwhelmed, the more you feel like you're sinking on a daily basis. So having developed the SIFT Workstation starting in 2008, so this is almost an 18-year project at this point, of a massive amount of digital forensics incident response tools that initially started as an education capability that most started using on their back end on being able to do digital forensics incident response on a daily basis inside their own organizations. So the premise of this talk is, what if you take an extremely vetted, beat to shreds tool and you combine it with a little bit of AI reasoning, and let's see what happens. This is entirely an experiment I decided to do based off of, and again, you'll laugh at this, Sans Marketing came to me and said, hey, Rob, we need you to do something digital forensics, which you're known for, and combine AI into it. And we have you scheduled for a talk in November 15th, and this date's gonna come key here in a second, November 15th on a Sunday to discuss your findings. I'm like, cool. So about 6 weeks prior to that, it occurred to me, because I'm playing around with Claude Code a lot, what if I installed Claude Code on the SIFT Workstation and see what it can do? So that was the premise of the talk. I did some experimentation, and my mind was blown. So let's talk about this. Sadly, not really sadly, 2 days before my discussion in the talk I was giving, Anthropic released their report using Claude Code on offensive operations, and I was a little bit bummed about this because apparently the Chinese had the same idea I did, which is combining Claude Code with a bunch of operational tools and to let it go. And that's essentially what we are doing here with Claude Code. Now, what we ended up finding here is that when you accelerate offensive operations using automated AI reasoning, you're able to achieve a speed that goes from things that used to take days, if not weeks, to seconds and minutes. And again, if you've started playing around with this or started taking a look at the speed of what is documented by Anthropic on what they observed, it is mind-numbing. So in order for us to be able to figure this out on the defensive side, we need to say, hey, the idea is matching AI speed with AI speed. So moving to the next slide, when you end up taking a look at what we are supposed to need to accomplish, being able to do manual hands-on typing to do digital forensics incident response work to discover what is in the AM cache? Let's do prefetch analysis. Let's do event log analysis. Let's combine that into a timeline using Plaza. Let's do memory analysis. All of these things combined take a lot of time. So, kind of curious, poll for the audience. In order for you to analyze completely a single system during incident response, from start to initial touching of the system, whether it's a deployed agent, you're imaging it, a post-image, by the way, you have the C drive image, how long does it take you from start to finish to create a report? Final report. Time frames. Throw out numbers. What's that?
3 days.
3 days. 2 to 3 days. What's that? Maybe a week sometimes. Anyone could do it faster. A day? I chose a day because otherwise the numbers just look unbelievable. What if I said you could do a full day of manual forensics to report in 14 minutes? Okay, we'll come back to this. All right. Everyone's going to be a little bit scared what I'm about to show you, but at the same time, you're going to like, wait, that's a game changer. And only someone who knows digital forensics into response can comprehend the report. So I don't want to say this is the end of human existence when it comes to digital forensics. There's no way, if you look at the output, I've put a bunch of resources in the Slack. If you look at the report, if you just say, figure that out, it is not, you need to have a formal understanding of what this looks like. So when you take Anthropic code, the reasoning side, you add an MCP and you add it to the SIFT workstation, the peanut butter and the chocolate here, we're sitting on top of something that does natural language processing. Basically in your Claude prompt, you basically ask it a question, and that question could be, do memory analysis. So here's essentially what you would do. You would ask a question. You have the memory image there. I'd like you to analyze this memory image and find anything malicious. It automatically knows based off of the context that you provided. And I redid this yesterday just as a test, a little bit of training, giving it contextual analysis of the different tools that are on the SIFT workstation, telling it how it works, maybe even just using public guides. I even had it go look at the man pages, run the commands, pull out the flags, understand what the command line interface is, and then it built the Claude MD file and the skills.md files that are sitting underneath each of the different tasks that you wanted to accomplish. So to give you an idea of what this looks like, I like demos. Essentially, I have multiple images in here, and I basically say, oh, that's the wrong one. You ask it to basically find evil in the memory image. It goes through, and you can see here, pay close attention to the minutes it takes for the overall processing. And again, I might just go and skip to the end here. It's because it's more fun to be able to see what the output is. Again, 18 minutes to do this image. And what we end up having here is a final report for the memory forensics. And this automatically creates this, by the way, because you asked it to. You end up seeing in here, the adversary achieved initial execution using WMI. And you can see me scroll through the overall report here. Finds a malicious binary, p.exe, into masquerading temp directory. You get a system profile. All this stuff is automatically determined for you. Threat actor context, attack chain, malware deployment, persistence. It's kind of going fast here because I have a limited amount of time. Code injection analysis, network connections, command and control, full malicious process tree, chronological activity. I didn't even tell it to do this. It just did it because I gave it context surrounding the tools, what this looks like. It probably went online saying, here's what an official report looks like. And false positives, it found F-response for the imaging capability for the agent. It recommends remediation tactics. And then it has the output reports that it has created here. All that took, a single memory image, about 18 minutes. The only reason it took that long is because I had to press yes on continue, 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 continue. Now I've gotten around that, but from initial build yesterday, just to test the theory one more time, an hour and a half of skill building, and I gave it a memory image, and then I hit go. Now, the resources I'm distributing at the end of the week, or end of today, sorry, end of week, I'm like thinking teaching here again. At the end of the day, I'm gonna give you access to all the memory images and C drive images, so you wanna replicate this, by all means, do it. Now, you need to test this stuff too. So, the brain behind this all is the Claude MD file. It basically is the prime directive, the orchestrator that's sitting behind the scenes. It is allowing you to do deterministic boundaries. You could hard code the tool paths. You don't need to let it guess. It is allowing you to say, run this capability, do not run this one. I also could give it some rules. Like I had to figure this one out too. Questions asked during a test. Run end to end. Don't ask for directions. Just move through the overall aspect of what I'm trying to get it to do. Then we need to build its skills. With so many capabilities built in the SIFT Workstation, we need to have some familiarization here that is going to hopefully reduce the overall context rot, be able to give it a path to success. And I'm not even building full skill-based MCP servers. I'm just basically giving MD markdown files for what the skills are. Here's your goals, here's what they do, here's how you potentially execute this. So if I say I'd like you to do memory analysis, it's automatically to be able to go do this. Now again, as a part of this, resources, I have all the skill files, all the Claude MD files, the overall one and the subdirectory one, all created. You could go back and replicate this. I have instructions, I have a notebook LM. You could ask it, I would like to go through and do this. It is all sitting there in front of you. Feel free, go about your business. So what about errors? This is where you could ask it and build into the contextual analysis and have something continually running behind the scenes that says, if you receive an error, I would like you to start performing self-correction. This also helps with the overall context rot that is achieved. Essentially, if you continue running the case again and again and again, it'll slowly over time forget the context earlier in the case. The other thing that's really fascinating here about this is that once you go through a single image in a single case, it'll remember aspects of that initial intrusion, especially if you're hitting other systems. So if you find a malicious code on one system, it's assuming it's looking for something contextual related on system 2, system 3, system 4. So the speed naturally increases as you're working through the different exercise. So because people don't like me talking about things, let me just show how this works. So demo time number 1. Here's the threat group. Here's what happened. We end up having Stark Research Labs. For anyone who's taken 508 at SANS, you'll definitively remember this network. We have a catalyst, lead researcher, Tim Dungan, inadvertently signaled project completion on Twitter. What a dork. What is he thinking here? Our Carbon Lab just consumed 9 gigawatts of energy and could likely power a small city overnight. What was I thinking? Going to be fired. The breach, adversary, Crimson Osprey, leveraging historical tactics of APT Hydra and APT Hammer. Yes, they're totally fake, by the way. Impact critical infrastructure, exchanged mail server and web server forced offline, compromised vectors, perimeter defenses bypassed, key administrative accounts, compromised, deep system persistent established. Local defense status, you're overwhelmed because you're using hands on keyboard. So, what you need to see, scope of the compromise, the hunt for persistence, the track lateral movement, and assess exfiltration. So once I have all this built, you have all of your disk images, memory images in here. The single command that I type, find evil, N. And I type this one out because it's fun to just watch, look how slow humans are. Type, 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 and this is the only command that I gave it for writing that comprehensive report. Write comprehensive report. And then, of course, I had to think about, well, what does that mean? And I'm like, I needed it even more simple. Comprehensive report in PDF. I'm like, my brain's on melt here. Backspace, backspace, back. In PDF. Good English there, Rob. All right. In we go. And when you end up watching this, you can see it's actually executing a lot of cool things. I'll just let this run for a little bit just so you can see what this looks like behind the scenes. Now this is on 16x. Of course, if you're watching the minutes, scroll by, you could tell that is not reality. It's finding things, finding things, finding things. In total, at the end here, we are at 14 minutes, 27 seconds for the analysis of that C drive. Pretty cool. Let's take a look, just to reemphasize the length of time that this took. This is the report that it automatically generated without any additional input. You can see the executive summary. And by the way, in terms of accuracy, since I compromised this system, I definitely know everything that's on here. This is 100% accurate for what it's finding here. It creates a timeline, initial access. And again, I'm releasing this report so you could go through it and examine it on yourself. Malware inventory, persistent mechanisms, PowerShell transcript evidence, did not miss anything. Network indicators of compromise. And actually, by the way, it kind of skipped by it, is the MITRE attack overlays on top of this too. And then went through remediation recommendations and steps. When you end up taking a look at this report offline, you're gonna notice that this is earth-shattering, fun, what the heck, an hour and a half configuration. There's gotta be a catch. As far as I can tell right now, the catch is AI weaknesses, context rot, self-correction. It works out of the box just like everything else in AI, but the more you repeat it and repeat it, repeat it, repeat it, over time, it is going to slowly become more dumb just because of the fact how that functionality works. The more you're running it against the same type of intrusion that you're taking a look at. So, and again, when we end up taking a look at this, I have some additional stuff at the end here I'm going to cover. We need to increase the speed of our incident response capabilities to match the speed of the offensive teams leveraging the same capabilities. This is amazing. Great proof of concept here. But one more thing I'm going to cover. One more thing. So in order for us, and I'm going to be talking about this at the RSA talk as well that I'm going to be giving in about 2 weeks, when we're starting to think about leveraging what we have as a community over what the adversaries and the threat groups and the criminal organizations don't have, is we have a lot of us, and they have a small development team. And they usually work in secret. They usually don't like to share their toys with one another. On the opposite side, we have the open source community. All of the things I'm showing you here, the SIFT Workstation, all the tools, all the capabilities, is open source. Now, if you noticed, a small little project that started on a weekend in someone's basement in November. By the way, I kind of use this as a gestation, but ClaudeBot was created over a weekend at the end of November. It really became popular at the beginning of January, in which the news started to really accelerate on it and logarithmically accelerated from that point. Part of the reason is you have a lot of eyeballs hitting it, a lot of developers simultaneously hitting that one point in time. And it explodes into a significant, revolutionary AI capability. Despite your skill level, despite if you're an AI developer, if you're really good at forensics, if this is your first foray into AI, what if we bring the army of cyber defenders together and saying, let's start working on this as a whole? Now, the other thing I noticed over the past couple years, and I've become fascinated with it, is that these concepts that the AI community is doing, called hackathons. Hackathons are designed to take an initial proof of concept and accelerate it into a worthy, true candidate capable of being deployed at enterprise environments that will reduce the overall capabilities or reduce the overall mistakes and increase the trust of these capabilities inside the organizations. So what the offensive teams don't have is 1,000 of us. And what if SANS, because we're giving this away for free anyways, we sponsor a hackathon trying to get the entire cybersecurity community working on this together. So the idea here is we have 2 tracks that we're going to have a bunch of cool prizes for. I'll give you a hint at one. For first prize, $10,000 for the team or individual that has the most significant development, and $7,500 for the second team. Those 2 tracks we're gonna be looking at is, number 1 is the forensic MCP engineering. We have a bunch of tools. Claude doesn't know how the parameters, outputs, and failure modes natively. I'd like you to take my proof of concept and accelerate it to 10 to 100x. So by the end of the hackathon, starting 1 April through May 15th, we're gonna be able to develop as a community something that you'll be able to have trust capability and potentially counter the offensive teams that are starting to leverage Claude Code. Track 2 is to cure the context rot issue. How would we potentially go about doing that? In the end, what I'm hoping for is having a total of $22,000, a total prize pool. I've reached out to Anthropic because I'm very interested in seeing if they're gonna be able to give tokens, so you don't have to spend a lot of cost developing this behind the scenes, so that they'd be able to work with us and be able to give resources to the community. I'm gonna have disk images, I'm going to have memory images. I have the SIFT Workstation. I have an exemplar case that someone's turned in. Steve Anson from SANS has developed his own backend, so you could look at that and saying that would be a pretty good implementation. You could build off of that. But the idea here is we want to work together as a community because there's a there that I'm looking at. And the question is, can we create a very solid incident response AI capability by 1 June? That's my challenge to the community, and I think we could do it. This is my contact information. The resources have been posted in the Slack channels, and more of those resources, I'm putting up a website. I was hoping to get it done tonight, but just like everything else, I can now say, hey, I get something done in a day. And that day is going to be protocol sift.ai. It's going to have all the resources, all the images, this presentation, a description of what it is, everything else. I'm going to build this probably up in about a day or two, just registered the domain yesterday. Contact information, everything else, resources online, and questions.
That was fantastic. Okay, questions. First, okay.
Hi, I was curious about the context rot problem and how you sort of navigated it. You mentioned that you didn't give Claude Code like all of the SIFT manuals at once. How did you go about like the lazy loading of it? Like, was there an orchestrator agent, or did you just tell Claude Code to like figure it out?
I use Claude Code as an orchestrator agent, and basically just started, hey, go through, look at the man pages, look at all the tools on the SIFT. I had an entire list of them. It'd run the man page, and I said, if there's no man page, run the tool, make sure it runs accurately, and see the command line flags, and then look it up online to see if there's any documentation. It literally is using Claude Code. And then I said, red team it, make sure it works. I actually asked the question like you just gave it. I'm like, because I'm learning too. I don't know how to solve this issue. If I did, I want to do a hackathon. So I'm trying to figure it out. But again, when I rebuilt it, it literally is natural language into Claude, asking the same questions you just did, and just continually fighting with it. And I fought with it for about an hour and a half before I said, okay, we're probably good enough. Let's go ahead and start running it through analysis. Great question.
I had my question is similar about context rot. I think, and some latest research just found, even with these million context windows, I mean, the first turn it gets dumb. I mean, you got a larger window, but it still gets done really quick. And I found this myself with OpenClaw. I tried to use a million window. I have to crank it down to compact it like 100,000 tokens.
Right.
For what you're doing, is it as easy as just start a new session to get rid of the context rot? I mean,
yes.
that's what we're doing, right? Anything different you're doing, or did you find a better way?
There's not a better way right now, but I'm looking at if you wanted to expand upon this in an enterprise setting and have it run across multiple systems at one time, doing like, let's use pre-fish analysis, looking for p.exe on 1,000 systems, that scale is going to create context rot pretty quickly. So on a single system, like standard forensics, no problem. Just restart, just like you do on, Claude will say, hey, we ran out of context, start a new chat. Here it's a little bit different because if we really want something enterprise worthy, it's going to have to be able to maintain its current data set across a longer period of time. Threat intelligence, all these other feeds that you could see where this thing could go. Yeah.
Yeah, I had a question on, you mentioned that it had 100% accuracy on
my report, yeah.
Exactly. My question exactly on that is that part of your SANS class? Did you do any assessment on, is Claude Code cheating, looking up answers online comparatively to actually running the...
Fair point, but the amount of detail that's in there, it would be shocking. Now I could probably disconnect it from certain things to be able to say, do not look up online, and to be able to do those checks. But great question. I assume no, but based on the amount of detail that's in there, it would be shocking that it didn't pull it from directly tool-based output. The other thing in there we do have is a log of every single command that it run, and the output files, every single thing that it built a report off of. So you do know that it's actually grabbing it locally, but is it inferring things online? Oh, good question.